welcome back to another Swift tutorial. In today's video, we're going to be learning how to build a full-fledged weather app. So the app we're going to be building is this right here, and this is actually using your current location to fetch weather data, and we show the daily forecast, including the day, an icon, low and high temperature, as well as the current temperature, and an hourly forecast. And as you can tell, this app is very similar to the native weather app that Apple has built and that they ship as a part of iOS. So with that being said, this is going to be a bit of a longer video. I might break it up into two videos if it gets a little dragged on. Please hit that like button down below if you're excited. Get your Xcode booted up and let's get into it. So as per usual, let's start with a new Xcode project. We're going to stick with the single view app and we're going to call this My Weather. We're going to save it on our desktop. Give ourselves a little more room to work by expanding Xcode. And let's start talking about the pieces we need to get this weather app working. So first and foremost, we're going to need the user's location. And the location is to allow us to get weather for the current area. We're going to use core location to accomplish this. The next thing we're going to need is a way to show a list of weather for the upcoming days. And we're going to use a table view to do that. We're also going to need a custom way to show that horizontal aspect of the table, which shows you the hourly forecast for the current day. And we're going to use a custom cell with a collection view to do that. And let's see, we're also going to need an API / request to get the data. So we're going to need that. And essentially, these are the 4 large components that we need to knock out to get this app up and running. In addition to this, we need to do some other little setup that we'll do together. And the first little thing we need to do is drag in some icons for different weather types. And I've actually gone ahead and created a couple for rain, cloudiness, and as well as sunny weather. And we're gonna start by going to our assets, and we're gonna create a asset called clear, rain, and cloud. So let's select clear and bring in this icon. Whoops, let's not bring them all in. Let's get rid of that. Put the sun there. For cloud, let's bring in the cloud. Whoops, not that one. Let's get rid of that. Let's bring in the cloud. And for rain, let's bring in the rain icon. Now let's go back to that view controller and let's start tackling these with easiest to most complex. So the table view is pretty easy to set up. So let's set up the table view first and foremost. So we're going to add a outlet for a table, and we're going to create a array for models, and this is going to be an array of, let's just call it weather objects that we're going to be creating later on. Let's just mock it down here as a struct so we don't get an error. We also want to set the table's delegate and its data source. Let's add them up here. So UI table view delegate as well as UI table view data source. We also want to register 2 custom cells. One cell is going to handle that collection view custom cell for the horizontal scrolling for hourly forecast, and one of the custom cells is going to just handle the normal vertical cell that shows the current day of the week, the weather icon, as well as the lower and upper temperature for the day. So let's just comment out register 2 cells. We also need to implement the basic table functionality, and that is number of rows. We're going to return number of models dot count, and we want cell for row. And for now, we're just going to return a UI table view cell. Make sure you have a simulator selected up here and hit Command B, and your app should still be building without any errors. Let's come up here and create a folder for our cells. So the first one is going to be, let's see, weather cell. The next one will be hourly collection cell. Let's right click on each of these and create the respective cells, which is a new Cocoa Touch class. We want a UI table view cell, and this one is a weather table view cell. Let's create a nib also by checking that box. And let's create one more. This one is going to be the hourly table view cell, like so. And let's just quickly add the identifier and nib functions in here to register the cells so we don't forget later. So static let identifier and static func nib. Just gonna return a UI nib. And let's spell static correctly. And it's going to be a nib with a name and a bundle. The name is going to be the same name of this class here and here. And let's copy this and also drop it on in to our other cell. And don't forget to update the identifier for both the nib and the property. And let's go back to our view controller. And in here, let's register those cells real fast. So let's say table register a nib. And the first one we want to register, we'll do hourly dot nib for the hourly dot identifier. And the next one we want is the weather table view cell. So let's just change this to weather. And let's also change it over here. Hit Command B. Your project should still be building. Something important to call out here, the order that you register cells is irrelevant as long as the cell is registered before it is used. That's the important thing. So a common question that I've gotten in the past, if the order matters, it does not. So this is basically a very simple version of the table. Let's focus on, well, actually, before we move to the location, let's go to the main storyboard and let's bring a table in and connect it and run the app and make sure it's not crashing. So let's grab a table view, drop it in, connect our table outlet, and let's add some constraints, which will pin the table to all four sides of the screen. Hit Command R, and let's see if this app crashes. Hopefully not. So app is not crashing. Awesome. So what do we need to do now? Let's move on to getting the user's location, which personally I think is kind of cool. So let's get rid of this. We want to import core location, which is the framework Apple provides to be able to do this. And let's see, let's put the location stuff in between the table and this comment. We're going to need a property, which is going to be the location manager, which is a CL location manager. And we're going to create a function, which is going to be, let's see, we'll call it setup location. And we're going to say location manager, first and foremost, the delegate itself, location manager, request authorization for when in use. So the user is going to get a permission prompt to allow location access when the app is in use. And after that, we're going to say location manager dot start updating location. We also need to come up here and add the location manager delegate. So CL location manager delegate. We're also going to have another property where we're going to capture the current coordinates of the user. And when testing this in the simulator, you can actually provide like a mock location. So we're going to pick something random. I think New York is one of the ones in the list. So I'll see if that's there. We'll use that. So we're going to say coordinates is a CL location. CL location, it'll be optional to begin with. And the delegate function that we want is location manager did update locations, I believe it's called. Let's see, did update locations. And this has a parameter, which is an array of CL locations. So we're going to say if locations isn't empty, and we're going to say, we're going to make sure that this, let's call this current location. But we're going to make sure this current location is still nil. In other words, we haven't set a location yet. So current location is nil. Then we can say the current location is locations.first. And once we have a location in here, let's actually stop updating the location. Save on battery life, and after we have a coordinate, there's no need to continuously monitor the location. And we're going to call another function, which is going to be request weather for location. And we're going to implement that in just a sec. Before we do that, in here, let's just print out the longitude and latitude for this location. So longitude is going to be current location dot, I believe coordinates. Yep, dot coordinate dot longitude. And let's do that for latitude as well. And let's actually do this as a guard. Let's actually guard this current location just to make sure that it's not nil before we use it, and we can get rid of this question mark for both of these. And let's print out both the long and the lat. So hit Command V, you should still be building. Before we run the app, something super important that we need to do is go to the info.plist and add a string in here, which is required by Apple when requesting any kind of permission. So we're going to add privacy location when in use. And you can tab it, it'll autocomplete it for you. And we're going to provide a string along the lines of please allow location to see local weather. So let's hit Command R to run this in our simulator, and looks like we don't get a prompt for location. So let's come up here and go to debug, and there's location in here, and you can see it's set to none. Let's set this to be Apple, and let's rerun the app by hitting Command R. And let's see, it looks like we still are not getting the location pop-up. So let's go back to the view controller and see what we missed. Let's see, so location setup is done in here, and looks like we're not calling this function. So obviously we need to call this function for anything to happen. So let's call this function in, instead of view did load, let's call this function in view did appear. We're going to do a super view did appear, and we're going to call this function. So hit Command R one more time, and there's our awesome location prompt. Let's do allow when using app, and we should get our longitude and latitude printed out here, which we do. So this is a longitude and latitude, I believe, for Apple, which is the location that we just selected. So that would be Cupertino, California. So cool. So now we have the location. And the next thing we want to do, as I mentioned, is implement the function to actually go and fetch weather. So to do that, we need to request the data from an API. So I'm going to head to my browser and talk about this API that we're going to use. So if you're not familiar, Dark Sky is a really awesome weather app available on iOS, Android, and I think other platforms too. And they actually offer their API services to get weather data for free to test and develop stuff. If you want to actually use it in your app, you do have to pay them. However, there are several other options out there for free weather services, but we're going to use this as an example. You can go here and get a free API key to test and play yourself. But basically, I already took the liberty of reading through their pretty well-defined documentation and finding out that this URL here basically returns a bunch of weather data for the supplied longitude and latitude. So if you look at this, we get a bunch of things like the hourly forecast, the daily forecast, current forecast. We've got temperature, time, weather, like description. We got a bunch of data in here. So what we need to do is take this URL and request from it the weather based on the location coordinates that we have. So let's come into our code, and instead of printing out the longitude and latitude, let's create our URL, which is api.darksky.net forecasts, my API key, which after this video I'll probably be deleting, so please create your own. Like I mentioned, it's free. Slash the longitude and latitude, and we want to exclude some fields because they also return minutely forecast, which is pretty crazy. So if we come back here, we can see that the longitude is this negative number and the latitude is this positive one. So let's come back here and replace the longitude, which is this one, with longitude, and this one with latitude. Next, what we need to do is use this URL to actually make the request. Let's get rid of my antivirus pop-up. And to make a request, we are going to use the URL session data task. So we're going to use a URL session dot shared data task with URL with the completion. Let's create a URL with a string, and we're gonna pass the completion block data, a response, and error. So data, response, error in, and in here we're gonna do a couple things. So first, we need to do some validation. And that validation is, let's make sure we got data back and that there is no error. Then we need to convert data to models / some object that we can use in our code. Thirdly, we need to update user interface. So the first part is easy. We can say guard let data equals data and error is nil. Otherwise, let's return, and we can print out something along the lines of something went wrong. Next, we need to convert the data to a model or some object. So Swift has this really nifty thing called JSON decoder, and what it allows you to do is basically create a struct object that conforms to the codable protocol. And as long as the properties that you put in here match the properties that the data returns, particularly in this JSON format. So for example, this latitude is a floating point, time zone is a string. If all of these match, you can use Swift's JSON decoder to convert the data to this object. The important thing is you need to make sure that you have accounted for all of the keys in the response. And as you can see, there's quite a few of them, as well as the nested ones in this hourly and daily array. So I'm going to pause the video here and type all of this out and come back in just a couple minutes. That way you guys don't have to sit and watch me type all this out. Now we've gone ahead and basically created struct objects here based on the keys in this JSON response that we're going to get. So the top level response is this thing, which we've called weather response. And the three things of note in here are currently, hourly, and daily. Each of those have a couple things, well, a lot of things. Currently has all of this stuff. Daily has an array of data of these daily weather entry objects. Same thing for hourly. We've got these hourly objects, and each of these objects, as you can imagine, for hourly is information about weather on the hour, and for daily it's about weather every day. So we're going to actually delete this weather struct that we initially created, which is what we're using in the models array. And we're going to use one of these. Our table view is going to show a list of the daily weather items. So we're going to actually put this daily weather entry into our models array. So let's come up here before we continue on our request of getting the data. So now that we updated that up here, we should hit Command B and still be able to compile the app. Let's come down here and continue with this. Now that we've defined those models, we're going to decode this response data to that model. And the way we do that is we're going to say this is weather results. And we're going to do a do catch statement, which basically tries to use JSON decoder to decode weather response from the data. If an error occurs, we're going to print out error and pass in the error property. And let's get rid of this print for the URL. To actually get this request to fire off, we need to add a .resume at the end of it. Slightly misleading terminology from Apple because this resume actually kicks off the initial request, which I guess they've called resume for whatever reason. But basically, once we've done this do catch, if we're successful, we're going to say guard let result equals JSON to unwrap the optional. And let's just print out something on results. So let's do result dot currently, and I think there's a summary on here. And if you're curious where these properties are coming from, these properties are in this all of these like JSON struct codable struct things that we created. So the reason we create them is so that this JSON decoder can map the data for us pretty conveniently. So let's hit Command R, and we should get something printed down here. So we get printed down here partly cloudy. So awesome. So if we actually look at the data, I actually pasted in the URL for this request that we're sending for Cupertino. It's partly cloudy somewhere in here. And I'm actually not going to waste time and try to find it because there's tons of data. So that said, what we need to do now is we need to update our models array and reload the table view. So the way we do that is pretty simple. Let's get the list of daily weather entries, and that will be results.daily.data. And we're going to say self.models append contents of entries, and then we just want to reload the table view. So let's do a dispatch queue dot main dot async self dot table reload data. Don't worry about this dispatch queue main async. At a high level, it just tells the program to make sure the stuff that's going on in here is done on the main thread, so it gets updated on the user interface quickly. I'm not going to get into the weeds of this, but just make sure you wrap your table view reload in it. So let's go implement our cell now for the table view. And if you recall, we have two cells. One is the weather cell and the other is the hourly table view cell. Let's just do the weather one right now, because that's what we're going to show first. So let's dequeue a cell. So let's cell equals table view dequeue reusable cell with an identifier. And it's going to be weather table view cell identifier index path as a weather table view cell. And let's click into the table view cell, and we're going to add a function in here to configure the cell, and it's going to be configure with model, and it's going to be daily weather entry. Let's go back to our view controller and call that configure function. Configure with models, which is our array of those weather entry objects. And let's see, what else do we need to do? So why is this complaining? This is saying cannot convert value of daily weather entry to expected argument type of protocol. So that doesn't seem right. Let's hit Command B and see what we messed up. So if we go back to this configure, let's see, configure with model daily weather entry. Let's click into this. This is a struct that is codable. So this doesn't seem right. Let's see what we messed up. Because we didn't use the correct function name. I've actually done this before. So let's not use conform. Let's use configure and hit Command B, and everything compiles. Let's go implement that table view cell. So each table view cell in our list is going to show the day that we're showing the weather for, an icon, the low temperature, and the high temperature. So let's do a couple things. Let's get rid of this commented code. Firstly, let's set a background color just so we can distinguish the cell a little more easily. Let's do gray actually. Let's add a outlet for day label. And we need two more labels for high temp label, low temp label, and we want a UI image view for icon image view. And when we configure the cell with a model, we want to assign all of this stuff. So firstly, the temperatures are pretty easy to do. We can say low temp label dot text equals model dot temperature low, which is a double. So let's convert this to an integer and let's put it in a string. And we also want to show the little circle to notate degrees. So I've actually opened that up in Google, but I forget what the keyboard shortcut for this is, but you can just Google degree symbol and you'll find it. So this little symbol. Let's do the same thing for the high temperature label. So again, this is going to be model.temperature high. Now what we want to do is configure the day that we're showing. And the way that we can do that is basically use another function. We're going to call daylabel equals, let's see, get day for date. And we're going to pass in a date. And it's going to be model, let's see, time interval since 1970. And we're going to pass in model dot time. And we need this to be, I believe, a double, if I'm not mistaken. We need to create this function, which is going to return a string, and it takes in a date. So let's see, what do we have going on over here? So we're saying get day for date, and we're passing in a date object. Let's create this parameter. Let's rather make this to be optional, because we're going to try to initialize the date from this timestamp in the model, and it might fail. Let's see, we still have an error here. If we look at the error, we say cannot assign a value of type string, because we want to actually be assigning the day labels text. And here we need to return a string. So we're going to say guard let input date equals date. Otherwise, let's return empty. And to get the day for the date, we're going to use a date formatter. And it's going to be date formatter, formatter.date style. I believe date style is the one we want, which should be a, we could use, let's see, medium for this, but actually let's do date format, gives us a little more control. And we want the day, and I believe the day is notated with 3 capital M's. If this isn't for the day of the week, like Monday, we can always look it up. And last, we want to return formatter string from input date. So hit Command B, and we should be good to go. For the icon, let's just default the icon to the sun icon that we brought in earlier. And we're going to compute the icon in just a moment. I think we called it clear. Let's head back to our assets file. And we have clear, cloud, and rain. And looks like that aligns with what we've got in here. Hit Command B. And let's create these outlets on our table views nib before we actually run the app and see the weather. So let's go to the weather cells nib and let this load. And we got to drag in a bunch of outlets. There are a bunch of elements that connect their outlets. So the first thing we want to drag in is a label. And let's put it in here like so. Let's set some constraints. So 0, 0, 0. And let's make the width of this 66, because it's easy. And this is going to be the high temperature. Let's grab one more label and drop it in. And this is also going to be 66 in width, so 0, 0. This one we don't want. This one's 10 actually from the label on its right. 0, and the width again is 66, like so. Let's also bring in an image view for our icon. And this one is actually going to be centered in the cell, both horizontally and vertically. And the height and width are going to be fixed, and we're going to fix them to be 60 by 60, like so. And that might be a little small, so let's actually bump up the width and height of this by going to the ruler and changing this value to be, let's say, 80, and this one as well as 80. Lastly, let's add one label. That's going to show the current day of the week that we're showing the weather for. So we're going to do 0, 0, 0, and 0. Hit enter. And let's connect our outlets and give this a spin. So let's right click this, grab our day label firstly, connect it. Next, let's grab our high temperature label and bring that all the way over here. Then we want our low temperature label. And let's connect that here. Whoops, I think we missed that. Let's try that one more time. Low temperature label. And lastly, we want the image view, like so. And let's not forget to set the identifier in the nib. So copy that, come back to the nib, and paste it in here. So hit Command R, and if I'm not mistaken, we should start seeing weather for the mock location. So look at that. We get weather. We get the sun showing up in here. Granted, it's not formatted that well. We get the low temperature and the high temperature. So pretty awesome progress if you ask me. Now let's get this looking a little nicer. Let's get the current temperature showing up here like the main weather app. And let's also work on the hourly stuff. So let's do some cleanup of this user interface. And actually, we're seeing March here for this day label, which is not correct. So let's actually fix that first. So I believe, let's try for the date format, 2 capital D's. That might be the day. Looks like that's the day of the year. Let's try 3 capital D's. And that's not accurate either. So let's actually search for NS date formatter. And there should be a reference that people oftentimes use from NS Hipster. Let's delete this window from my antivirus. And let's see, this is what we want. So we want, let's see, number formatter. So let's see. So what we want is, instead of M or D here, we want 4 E's, and if we build and run that, you should see the day of the week, and hopefully they're in order. So today's actually Wednesday, so we got Thursday, Friday, Saturday, Sunday, so on and so forth. So let's decrease the size of this, the icon for the weather. And instead of actually decreasing the size, what we're going to do is increase the size of the cell height. And on the image view itself, we are going to set a property, which is going to be content mode, scale aspect fit. Let's go to the view controller. And in here, we're going to say height for row at index path. And we're going to return 100. So let's build and run that, and looking a lot better. Let's increase the size of the temperatures over here, and let's make both of them centered. That way they won't be kind of smushed to the icon. So again, let's go back to our cell. And in here, we're going to say for the high label and the low label, the text alignment is centered. And let's do that for low temp label as well. Let's get rid of the background color that we added in here. And let's see. We also want to compute the icon. So right now we're just using clear. The way we're going to do this is by using the summary of that date. So there's a summary property on the model that we're passing in. So we could actually use this, but actually let's use the icon. So there's an icon property on here, and what we're going to say is if icon contains clear, we're going to use the clear icon, else if icon contains rain, we're going to use the rain icon. Otherwise, we'll use the cloud icon. So this one's clear, rain, and lastly cloud. So let's update these and hit run, and let's see what we get. So we can see here we are showing rain for today. Sunny, sunny, rain, rain, sunny, and it looks like no cloudy, which is cool. So that takes care of this. Let's move on to showing the current temperature at the top of this table. And to do that, we are going to utilize the table's header. So let's go back to the view controller, and in the function where we reload the table views data, which is our fetch function, we're also going to say self.table.table header view equals create table header, and put a self dot before there. This function we have not created yet, so let's create it. It returns a UI view, and we're going to say let header view is a UI view with a frame 0, 0 view.frame.size.width. Same for the height. And let's return this header view. Let's set a background color to this of red, just so you guys can see where this header view is going to go and what we're going to do with it. This space up here, and we want to show a label with the text current location, the summary for this location, as well as the current temperature, nice and large in the middle of this red header view. So let's create our three labels. Our three labels will be summary label, which is a UI label, and we want a location label and a temp label. So let's just assign some dummy text to this for the sake of just quickly positioning everything on the screen. And let's see, summary. Let's assign frames to all of this. So we want the top label to be location. So we want the frame to be a CG rect with an X of 10, Y10, view.frame.size.width -20, and a height of, let's say, the header views height divided by 5, so 1/5 of the header view's height. For the summary label, we're going to do the same thing. So let's copy and paste this CG rect. The only difference in here is going to be, this is going to be 20, and we are going to add the height of the location label. So let's say this plus frame.size.height. And lastly, we have the temperature label. So let's also go and paste in this business. And this is going to be, instead of the location, we're going to add the height of the summary label as well. So plus this, dot frame, dot size, dot height. And the width we can keep the same as well. The height for this is going to be this divided by, I believe, 3. Let's try 2 and see if that overflows the header view. Let's not forget to add these as subviews to the header view. So we have a temp label, a location label, and a summary label. And we want all of this to be centered also. So let's set all of the text alignment to be centered. Location, summary, and temp. And we're going to bump the size up for the temperature in just a second. So it looks like we need to set this to be the text. And let's hit Command R, and we should be able to build and run. And okay, cool. So we've got some stuff going on here. Sizing isn't completely the way we would want it, but I think this is sufficient for the sake of this demo. So let's increase the size of the temperature and actually assign the proper text strings. So location will stay the same. Let's increase the size of this temperature label. And we're going to assign a font with name, Helvetica, bold. Let's try 32. And what we're going to do in the function where we get the data, we're going to assign the current weather data to a property so we can access it. And we're going to get that current via the results.currently, and it's a current weather. And we're going to say self.current weather equals current. So we're going to come up here and create a variable called current, which is current weather. Let's go back to this header view function. And what we can say in here now is the text for the temperature is self.current.temperature. And for the summary label, we can say this is self.current.summary. And let's actually wrap this inside of a text block like so. And the reason we're going to do that is because we're going to add on the degrees notation. So if you recall, in the cell, we added this little circle degree thing in the cell. So let's go back to the view controller and add in this. And let's hit Command R before, rather, let's check this error first. String interpolation produces a debug warning. The reason for that is because this is optional. So let's actually unwrap it. So we're going to say current weather, and we can say current weather. So let's hit Command R. We would need to return a UI view in here. And let's see, did I spell it wrong? Looks like it's spelled correctly. Looks like we have an error over here. Self.current weather equals current. I think we called it current instead of current weather. Let's let this run, and we get the current temperature with a decimal. Actually, we could probably pop this off. We get the summary, and we get current location. So looking pretty good, in my opinion. Let's get rid of this red color, because it's slightly obnoxious. And let's set a nice background color to this. And we can do that by searching for some hex in Google, and let's pick a nice blue shade for the background. Let's pick something a little darker, so this works. And what you can do is you can copy the RGB values in here, and let's set the header view dot background color equals a UI color with red, green, and blue. So let's paste in those values. And lastly, blue, alpha is 1.0. Let's run this app, and we should get a nice blue in the background of this. Let's also set this at the background of the cell. So cell.background color is this UI color. Let's get rid of all of this. And let's see, cell.background color equals a UI color. This looks correct. Let's run it. Hopefully it's all blue now. Beautiful. So we can see that the actual view is also white still because the table's cells are blue, but the background is white. So let's actually take this color assignment and also assign the background color of the table and the view. But let's spell view correctly because that's important. Run it one more time. And we've got a weather app. So the next piece to do, which I'll probably do in a follow-up video because this video has gotten very long already, is add another cell for the hourly forecast here that the user can scroll horizontally. So thank you so much for watching. If you enjoyed this video, drop a like below, helps out the channel and the video quite a bit. Leave a comment if I skipped anything that you're confused about. Subscribe if you're new for daily videos, and I'll catch you in part 2 so we can add the hourly and finish up this.